I'm recording this video as a set of other videos to be followed in order to cascade my knowledge and skills that I have gained while studying for the AWS certification that I have earned in the beginning of this year. So we start in giving a overview description of the certification as it's advertised by AWS. The certification is intended for individuals who have been working in the field of data science and have more than 1 year of experience developing, architecting, or running machine learning/deep learning workloads in the AWS cloud. Additionally, candidates should have the hands-on experience and knowledge in how these models work, how it can be developed, how it can be run, and they should have the ability to apply model training, fine-tuning, deployment, and to recognize the best practices when it comes to MLOps. So the plan is to have a separate video which explains the content of each of the 4 main blocks or sections of the examination, which are as follows. There are 4 main blocks of the AWS ML certification, which is mainly data engineering, that weighs 20%, EDA or exploratory data analysis, which weighs 24%, modeling, which is the biggest and most important section, it weighs 36%, and the 4th section is the ML implementation and operation, which weighs 20%. So as I said earlier, the plan is to have one dedicated video which explains the main topics within each section, and at the end of each section we'll have sample questions that we will answer, and which like application of the explanation of the main topics, and these sample questions are identical exam questions that you might encounter while sitting for the exam. So if we start with the first section, which is section number 1, data engineering, it mainly focuses on data collection, storage, preprocessing, and transformation for machine learning. So it's the first primary step when working on an ML project is like to think where this data can be collected, how it can be collected, where is it stored, and how to store the output as well, how to process it and transform it to make it ready for ML training. The main topics that we'll aim to tackle in this section are as follows. We're going to talk about S3, Kinesis, networking, VPC endpoint. We're going to talk about the Glue ETL, data pipelines, Elastic MapReduce, AWS step functions, and as I said, we're going to end it with some sample questions. We're going to tackle these questions. We're going to provide some strategies, how to read the questions, what to look after, and how to select the best correct answer from the given choices. So the first topic is Amazon S3. I'm sure that most of the people who have experience in the AWS cloud, they know what does S3 stand for, and it is a storage tool which allows people to store files known as objects in buckets which known as directories. So S3 can be used as a data lake or centralized architecture for data storage. So whenever you notice any question, something related to data lake or centralized architecture, then you have to think of S3 as a potential solution for that. Within S3, you have the lifecycle configuration, which allows you to move objects between different storage classes. And the most known or the most used storage classes, it could be S3 standard, which is mainly used for highly frequent access data, such as big data analytics and content distribution. If we have data which is needed to be infrequently accessed, then we can go to the second class, which is S3 standard infrequent access, and which is mainly used for backups and recoveries. The third S3 storage class that we're going to talk about is Amazon Glacier deep archive, which is used for long-term storage and it's less costly. The fourth S3 storage class is S3 intelligent tiering, which simply it allows users to move objects automatically between tiers based on the data usage. So this is a figure which simply depicts or summarizes the available S3 storage classes. And as you see, the line goes from most frequent access data to less frequent access data. And for S3 standard storage class, we're mainly talking about frequent data. If we have less frequently accessed data, we can go for S3 standard and frequent access. And if we are just like saving data for long-term usage with less access, then we can think of archive or S3 Glacier Deep Archive storage class. So the two most important factors that someone should consider before choosing which S3 storage class they should go after is first how frequent the data should be accessed. So frequency of accessing the data. And the second point is it's the cost. How much cost I should incur with data. So if I'm looking for less costly solution, then I should go for deep archive. If I don't care about cost, then I can go for the S3 standard storage class. The second topic that we're going to talk about is S3 encryption. So there are two methods of encrypting objects within S3. The first one is what we call SSE-S3, which mainly encrypts S3 objects using keys handled and managed by AWS, and this is the default one. And the second encryption method is called SSE-KMS, or what's known as key management service, and it gives customers an ability to generate these KMS and with additional security in order to manage encryption. So if we are after like more secure solution or like more with more security, then we should go for SSE KMS. If we are okay for AWS to handle and manage encryption, then we should go with the default one, which is SSE S3. The next topic that we're going to talk about is Kinesis. So Kinesis is known as AWS streaming service, which is used for application logs, matrix, IoT or Internet of Things, click streams, and real-time big data. So whenever the question is asking you for a solution which entails about big data, application logs, click streams, then we should think of Kinesis. Within Kinesis, we have four main pillars that every candidate should know, is which can be summarized as follows. Kinesis streams, which is mainly used to ingest and process large amounts of streaming data in real time with low latency. We have Kinesis Analytics, which allows users to perform real-time analytics on streams using SQL. We have Kinesis Firehose, which simply loads streams into different destinations, such as S3, Redshift, Splunk, or Elasticsearch. Kinesis Video Streams is meant for streaming video in real time and to create ML applications with other AWS services such as AWS SageMaker or AWS Recognition Video. So the key thing is to know is like Kinesis Streams does the processing of data in real time. Kinesis Firehose, it helps us to load the data into other destinations in near real time, not real time. So if we want to talk more about each of these four pillars, with Kinesis Streams, it's useful to know that we have producers and consumers. Producers, we can think of it as like the data sources or the applications that send data to Kinesis for ingestion. It could be security cameras, smartphone cameras, or audio feeds. Whereas consumers are the applications that retrieve and process the data stored in Kinesis Streams, such as AWS SageMaker, Amazon Recognition Video, etc. It's good to know that streams are divided in ordered shards or partitions. And one important feature of Kinesis Streams, it's the immutability. So whenever data is inserted in Kinesis, it cannot be deleted. Kinesis Firehose, we can think of Kinesis Firehose as a fully managed streaming service which sends data to other destinations. As we said earlier, Kinesis Firehose helps us to send data to other destinations, and these destinations it could be S3, Redshift, Elasticsearch, Splunk, or simply HTTP endpoints. One important capability of Kinesis Firehose, it's serverless data transformation. So whenever a question depicts something about data transformation with Lambda, then we can think of Kinesis Firehose, which entails this capability. As I said earlier, Kinesis Firehose, it helps to stream data near real time, whereas Kinesis streams, it helps streaming data in real time. Within Kinesis Firehose, we also have the capability to do automatic scaling, depending on the volume of data. And there is no need for data storage in Kinesis Firehose. So just Kinesis Firehose, it helps you to stream your data, okay, without the data storage. And we can use its built-in method to transform the data to Parquet and load it to S3. So there is no need for data storage. So whenever the question is asking for a solution which doesn't need data storage, but it requires data transformation, then we can think of Kinesis Firehose. Next, Kinesis Data Analytics. So as I said, Kinesis Data Analytics helps us to do data aggregations and to transform statistics and insights from data using SQL. But within Kinesis Data Analytics, we can also utilize machine learning. So there are two models which are currently available within Kinesis Analytics, and it helps us to perform machine learning. The first model is called random cut forest. And random cut forest, we can think of it as like anomaly detection algorithm, which help us to identify outliers or anomalies within a data set. The second algorithm is hotspots. And it's simply clustering algorithm, which helps us to locate and return information about relatively dense regions in our data. So these models, it could be used in different business cases, such as fraud detection, network monitoring, and cybersecurity. The next topic that we're going to tackle is networking, or VPC endpoint gateway. So VPC is what's known as virtual private cloud. And when we combine VPC with endpoint gateway, we can think of it as a networking feature that allows users to privately connect their VPC to AWS services, such as AWS SageMaker, without the need to go through the public internet or internet gateway or VPN or net device. So in a nutshell, we can think of VPC endpoint gateway as like it helps us to establish a private connection between our VPC and the AWS service without needing to send traffic over the public internet. So just like private connection between the VPC and the AWS service. And this is established or like achieved through using the VPC endpoint gateway networking feature. The next topic that we're going to cover is Glue ETL. Glue ETL in AWS, it helps us to run code using programming languages such as Spark, Scala, or Python. Glue ETL is serverless, so you don't need to worry about configuring or managing the resources. Glue ETL will do this for you. Within Glue ETL, you can have data catalog, which helps you to make the data available to Athena or Redshift Spectrum. Glue ETL, it can do the following jobs. It can transform, preprocess, clean, and enrich the data that you have. Within Glue ETL, you can have a Glue scheduler, which like helps you to schedule jobs at a certain time or a certain day. And then within Glue ETL, also you have Glue triggers, which helps you to automate job runs based on events, such as pushing a Parquet file to S3, which will trigger a transformation job on the data and then save the data for a database. So In a nutshell, Glue ETL offers you three tasks. It helps you to build the data catalog. It helps you to do data transformation and processing, and it supports you in scheduling and running jobs based on certain requirements. The next topic is about data pipeline. So data pipeline, we can think of it as orchestration service that runs on EC2 instances. However, it offers more control over the environment and compute resources. So you can manage, or like you can manage the resources that you want within your data pipeline. It's commonly used in cases of when you want to do ETL unstructured data, and when you want to move data to cloud, or when you want to do Amazon DynamoDB backup and recovery. So if we think, so data pipeline, it does ETL, but it does ETL on unstructured data, and it gives you more control over the environment. However, Glue ETL, it's like a serverless. It's serverless, and it can manage resources for you. This is the main difference between data pipeline and Glue ETL. So when you want something which is serverless, you need to go for Glue ETL. But when you want something which gives you more control over the environment and compute resources, then you have to choose data pipeline. The next topic that we're going to talk about is Amazon EMR, or Elastic MapReduce. So Amazon EMR, it helps you to employ Amazon EC2 instance to analyze big data across a network of virtual servers. Whenever you see, or whenever you have like data of petabyte scale, and you need to do pre-processing for this data, then you have to choose Elastic MapReduce, which helps you to do data processing, perform analytics, or use machine learning on a huge amount of big data. It's also good to know that Amazon EMR, it uses Amazon S3 to hold data sets for analysis, like at this data storage, and for processing output. The last topic that we're gonna talk about on AWS data engineering is the AWS step functions, and we can think of AWS step functions as low-code visual workflow service that it eliminates the need to manually orchestrate application components and to manually define how they should work together. So if you want like an automated pipeline which helps you to orchestrate how certain application would work, then you can use AWS step functions. It's used for building distributed applications. It's used to automate IT and business processes, and it's also used to build data and machine learning pipelines using AWS services. Other services that I would advise for you to know more about and to read their usage on AWS website is AWS Batch, which is known as a fully managed batch computing service that plans, schedules, and runs ML workloads across a full range of AWS compute offerings. The second one is AWS Migration Service, or DMS, and it's a managed migration replication service that helps you move your database and analytics workloads to AWS quickly. We also have Amazon SNS, or Simple Notification Service, and it simply sends notifications in two ways. There are two types. You have SNS A2A, which allows you to send messages between systems, and SNS A2P, which helps you send messages to customers. Other services that also you need to worry about is definitely AWS Lambda, which is known as a serverless compute service, and it helps you to run code without configuring any infrastructure. AWS Lambda can be triggered by events coming such as from API gateway, SNS topics, or S3 bucket changes. It's also good to know about EFS, or Elastic File System, and which is used for or built for petabyte scale data. It has an automatic scaling where it automatically grows and shrinks as you add and remove files with no need for management or provisioning. It can be shared by multiple instances as well. FSx Cluster, it's a fully managed shared storage built on a high-performance file system. It can be used to launch and run cost-effective, large-scale machine learning and high-performance computing jobs. Other topic that you need to know about is also AWS Redshift, which is simply a cloud-based data warehousing service. It's used for columnar data storage, and it's optimized for SQL OLAP or online analytical processing workloads. And within AWS Redshift, you have something what we call Redshift Spectrum, and which allows us to run queries directly against data stored in S3 without the need to load the data into Redshift tables. On the other hand, we have AWS RDS, or Relational Database Service, which is a managed database service for row-based storage. So AWS Redshift for columnar data storage, whereas RDS is for row-based storage. And RDS is optimized for what's called OLAP, or online transaction processing workloads. We have different available relational database management services, such as Amazon Aurora, PostgreSQL, or MySQL. Okay, so this covers the explanation of the main topics which you might encounter while studying for the data engineering section for the AWS ML certification. Of course, this gives you like an overview, but definitely you should go and dig deeper on each of the topics that we talked about, and to make sure that you are grasping all their different use cases, their components, when to use it, and why to use it. And now we're gonna tackle some of the sample exam questions, which you might encounter in your upcoming examination. So the first thing that we need to know is that we have to read the question, and then we have to look into keywords that will help us to figure out an answer without looking into the answer choices. So if we read this question, it's telling us what networking component you should use to ensure that AWS services only access your data in Amazon S3 using AWS private link without going through the public internet. So we should think first of all for keywords here. So definitely they are asking about something about networking component, and they're asking us to think of a solution which helps us to connect our VPC to the AWS service without going through the public internet. So public internet is like without going is a keyword, public internet is a keyword, and network components another keyword. So of course we did touch base on that in the explanation. And then when it comes to networking, we should think of VPC endpoints. And if you look of the choices, security groups, I think it's not relevant. VPC endpoints, we did talk about that, and it's the best solution in order to use, and it's the solution which is being implemented by AWS in order to allow users to connect their VPC to the AWS services without going to the public internet. So it's definitely solution part B, which is the correct answer, VPC endpoints. Question 2, they're asking us which of the following options would allow you to ingest, transform, and store data in Parquet form, streaming data from sensors. So they're asking about streaming data from sensors, which we should think about Kinesis because it's streaming data. But within Kinesis, we have Kinesis Streams, Kinesis Firehose, Kinesis Data Analytics, or Kinesis Video Streams. And because they're asking us to ingest, transform, and store in Parquet form, so we have to think of Kinesis Firehose, because Kinesis Firehose has its built-in method, which allows you to transform data and like put it in another destination, such as S3, Splunk, or HTTP endpoints. So from the available choices, of course, Kinesis Data Analytics, it doesn't allow you to store, like to transform. It just allows you to do some like aggregations or calculations, or like use the ML algorithms to get data insights from the data. Kinesis Streams helps you to stream the data in real time, but Kinesis Firehose helps you to ingest, transform, and store the data and put it into another destination. So definitely it's option number C is the correct answer for this question. Question number 3, they are asking us, you have data stored in S3 in the Parquet form, and you want to analyze and visualize the data. How can you achieve that? So definitely we are talking about something which around S3, data saved in S3, and we want to analyze and visualize the data. So the options that are giving us, AWS Glue, Athena, and QuickSight, data pipeline and QuickSight, Lambda function, Athena, and QuickSight, AWS step functions, and QuickSight. For your knowledge, we didn't talk about QuickSight, but QuickSight is simply a visualization tool in AWS, like Tableau or Power BI. So this is like, it's called QuickSight on AWS. So because we have S3 and we want to analyze and visualize data, so we can think of AWS Glue, which helped us to do ETL in the data, Athena to query the data, and QuickSight to visualize the data. Pipeline, it can be used as orchestration service, like for huge unstructured data, which is not needed here. The question, it doesn't entail that. Lambda function, it can be used, but here they're asking us to to analyze and visualize the data from S3 directly. So AWS Glue would be the best answer, because it helps us to use the data which is stored in S3, build the data catalog, and then use Athena to query the data, and QuickSight to visualize it. So it's definitely option A is the most correct answer in this context. Question 4, they are telling us which AWS function helps us to convert workflow into a state machine diagram so it becomes easy to debug. We also did talk about that as like AWS step functions, which is a low-code visual solutions that is used to build distributed systems or to automate IT processes. And so from the available choices, we have AWS Glue, AWS step functions, AWS data pipeline, and EMR. Data pipeline and EMR are used for data processing. Glue is used to build data catalogs and do ETL, but AWS step functions is the solution which helps us to like convert workflow into state machine diagram or like visual, so it can be easy to debug. Question number 5, they are telling us you have been given access to streaming data from a game application. Streaming data here. What are the required tools to analyze the stream data effectively and detect anomalies? So they're asking us streaming data, and then how can we analyze the stream data effectively to detect anomalies? So for when we're talking about streaming data, of course, we should think of Kinesis. And for Kinesis, if we look on the options, we have Kinesis Firehose and Kinesis Data Analytics, or Kinesis Firehose and QuickSight. So for streaming data, we can also always think of Kinesis Firehose, but for analyzing the streaming data to detect anomalies, we can use Kinesis Data Analytics, because within Kinesis Data Analytics, we have ML algorithm, which we talked about before. It's called random cut forest, which allows us to detect anomalies in the data. So Kinesis Firehose to stream the data, and Kinesis Data Analytics to analyze the data and detect anomalies. So in this case, option number B is the correct answer. The last question that we're gonna tackle here in this section is as follows. So they are asking us, you are working on a competitor analysis project in a retail company. You are required to stream and ingest the product's data to a data lake. Then you should be able to compare those products to the in-house ones and visualize performance using business intelligence dashboards. Which of the following would be the best and efficient solution? So also, we are required to stream and ingest data. This is the keywords here. Data lake is another keyword. And we should think of visualization this data using BI dashboards. So streaming data, definitely Kinesis. We should think of Kinesis Streams or Kinesis Firehose. Data lake, we definitely should think of S3 in this case. And for doing analysis, we can think of Kinesis Data Analytics. And for visualizing performance, we can think of QuickSight. So this is like without looking into the options, we have like few ideas in mind what could be the right answer. So Kinesis Streams, Kinesis Firehose, Kinesis Data Analytics, S3, and QuickSight. We're looking into options. The first option is Kinesis Firehose, Elasticsearch, Kafka. So Kinesis Data Firehose, it helps us to do data streaming, but neither Elasticsearch or Kafka can help us to do the data lake and to build the BI dashboards. Option number B is telling us Kinesis Data Analytics, S3, and QuickSight, and this can help us to do the analysis. But it doesn't allow us to stream the data. So we are still missing the first part, which are required to stream and ingest the product's data. So option B is wrong. Option number C, Kinesis Data Streams, S3, Lake Formation, and QuickSight. So they're asking us to stream and ingest the product's data to a data lake. Kinesis Data Streams, it helps us to stream the data, but it doesn't help us to send the data to another destination. So we still need like a solution or a tool which helps us to take the data from Kinesis Data Streams to S3. However, if we go for Kinesis Data Firehose, it helps us achieve the purpose of streaming the data, sending the data to another destination, which can be S3. Within S3, we can do the data lake or the lake formation, and we can then push the data to QuickSight and do and develop BI dashboards that help stakeholders to drive insights about the product competitive analysis. So yeah, in this case, we should go for option D as the most correct answer. This takes us to the end of the data engineering section. I hope that you find it useful. As I said earlier, you should take this video as like explanatory video for you to know what are the main topics that you should focus on while studying for your AWS ML certification, and you should read more about each of the topics we talked about. And I hope that the questions that we tackle, it gave you a glimpse or taste of real exam questions that you will tackle while sitting for the exam. The next video we will talk about exploratory data analysis. We follow the same strategy. We'll cover the topics, and we're gonna end up with sample questions that are identical for the certification exam questions. Help potential candidates who want to sit for the examination. And today we're going to cover the second part of the course, which tackles of exploratory data analysis of the exam. And as we know, as data scientists, exploratory data analysis is like a primary step while developing end-to-end ML project. And it simply allows data scientists to drive insights and observations on the data and what kind of transformation they should apply before giving the data for ML training. So what we're gonna do on this section, what are we gonna cover? We're gonna cover the tools and techniques that allow to understand, analyze, and prepare data for ML modeling. We're gonna follow the same strategy as the previous video, where we're gonna cover the content of the main topics. And then we're going to end up with sample questions, which help us test what we covered and give us also a taste of real exam questions. The main topics that we're going to talk about in this section can be summarized in the slide, where we're going to talk about data distributions, feature engineering techniques, such as to handle missing values, outliers, class imbalance. Then we're going to talk about data transformation and encoding. We're going to touch on data shuffling, AWS QuickSight, AWS Athena, and AWS Ground Truth. If we start to talk about data distributions, so we mainly have um, different types of data distributions, but they can like fall under these three sections. The first one, it could be probability density function, which it's a probability distribution of a continuous random variable, such as the probability of observing different heights within the population. So when the variable that we are testing is considered to be continuous, then we should expect to have probability density function, and it gives us distribution of this continuous random variable. The second type is probability mass function, which describes the probability of discrete data, such as the number of questions answered correctly in a test, which could be like out of, like if the test has like 10 questions, what's the probability that the student did answer like 4 out of 10 questions correct or 8 out of 10 correct. The third probability distribution is Poisson distribution. And Poisson distribution is a specific type of discrete distribution. So its Poisson distribution is discrete distribution where it helps us observe the distribution of a discrete variable. That it represents the probability of a certain number of events occurring within a fixed interval of time or space. So if we think of a practical example of Poisson distribution, we can think of call centers, where call centers use the Poisson distribution to model or to determine the number of expected calls that this center will arrive at the specific time interval. So it's the same theme. We are talking about certain number of events. Here we are talking about certain number of expected calls. So calls represent the events which will occur within specific time intervals, such as like within 30 minutes. So this is what Poisson distribution is about. If we dig deeper into more distributions, we can also have Bernoulli distribution and binomial distribution. So Bernoulli distribution is also a discrete probability distribution, which models the single trial with two possible outcomes. So whenever we are thinking of a probability distribution which has one single trial with two possible outcomes, it could be success represented as 1 or failure represented as 0. This could be Bernoulli distribution. And one popular example is like flipping a coin, which gives us head or tail. So because when we flip the coin, there are only two possible outcomes, and within a single trial, this is called Bernoulli distribution. Whereas binomial distribution, it represents the sum of Bernoulli distributions. So it's the same idea of Bernoulli distribution, where it's discrete. It models two possible outcomes, success or failure, 1 or 0. But within binomial distribution, we can have different trials. So it's the sum of Bernoulli distributions, and it describes multiple events that exactly having two possible outcomes with the same probability of success or failure, such as probability of a student passing or failing an exam, or probability like of a team winning a championship. So here you have like different trials, but there is two possible outcomes, either success or failure, and it's like multiple events or multiple trials. So Bernoulli distribution is like discrete probability distribution with a single trial and two possible outcomes, whereas binomial is the sum of those Bernoulli, where we have multiple trials with only two possible outcomes, either success or failure. The next topic that we're going to talk about is feature engineering. And I think it's one of the most important topics in data science, where if we are developing an end-to-end ML project, and before getting ready in a stage where we're able to test different fancy ML or deep learning algorithms, we should prepare the data and make it appropriate and properly presented for the model to handle it. Otherwise, we're going to have different errors. So the first the feature engineering technique that we're going to cover is how to treat missing values. So one of the most challenging parts that we could receive a data set from our stakeholders, but this data set might have a lot of missing values, whether in numeric or categorical values. So what are the kind of strategies that we can think of? The first one is we can think of dropping attributes or dropping rows, in other words, that has too many values, which is like less favorable because this might end up us losing some potential good data. The second strategy could be to fill in or like replace these missing values with a median or a mean. And it's worth noting that median is better in case of outliers. So if we have a lot of outliers in the data, like we have skewed unnormal distribution, then we can think of the median to be used, which is better in this case. The third strategy that we can think of when treating missing values, we can think of KNN or K nearest neighbors, where we can find K nearest most similar rows and average their values for numeric data. And the fourth strategy that we can use is to build a machine learning model in the feature engineering stage to impute this missing data. And we can either do deep learning model or simple regression model, but it's worth noting that deep learning works well for missing categorical data, and regression, it works well for numeric data, which helps us to find relationship between the missing feature and other features. So to sum it up, it's very important to know these are the 4 most prominent techniques to treat missing values. We can either drop these missing values or these rows, which is the least favorable technique. We can use median or mean, or we can apply KNN, or we can build a machine learning model which can impute this data. Deep learning works well for categorical data, whereas regression works well for numeric data. Then we're going to talk about how to treat imbalanced data. So if we are doing logistic regression and we are having 2 classes, binary classes, true and false, true would be, for example, less represented in the data, or the data distribution would be like 95% for false values and 5% for false values. So we should think of techniques in order to treat this imbalanced data before training a ML model. And the 4 prominent feature engineering techniques to treat imbalanced data, it could be to oversample the minority class. So for example, to oversample the true class if it's underrepresented. Or we can think of undersampling the majority class. The third one we can think, which is very well known in the field of data science, is to use something what we call SMOT, or synthetic minority oversampling technique, where it helps us to generate new samples or to augment the new samples to either undersample majority class or oversample minority class. And good techniques in the field, as I said earlier, it's SMOT. And the fourth feature engineering technique that we can use to treat imbalanced data is to adjust thresholds between classes. So if we're talking about logistic regression, we can adjust the thresholds or the probability for the model in which it predicts if the class is positive or a negative. So if we put this in practical example, let's say we're having data set and want to predict a fraudulent outcome. So we need to predict if an event is fraudulent or no. So it's like true or false. And the fraudulent class is is highly like underrepresented. So we have like a high imbalanced data. So we can think of oversampling the fraudulent class or undersampling the non-fraudulent class in order to make the data set more balanced. We can also use mod to generate more samples or more synthetic samples of the minority class, which is the fraudulent class in this example, or we can simply adjust thresholds between fraudulent and non-fraudulent classes. Uh, Also to continue on how to handle outliers. So if we have outliers in the data, or like we have data skewness, in other words, we can think of variance and standard deviation in order to detect these outliers. So variance, it helps us measure how, it's like statistical measure, which helps us measure how the data is spread around the mean. So if the variance is high, this indicates the data points are widely scattered and far from the mean. Whereas standard deviation is also a statistical measure, and it's simply the square root of the variance. And it also indicates the extent of variability or dispersion within the data set. So if we do like a test for data set and we determine the variance and standard deviation, and we find out that there is like high variability or like data points are widely scattered from the mean, then we need to think how to remove these outliers and treat data skewness. And to do that, there are various feature engineering techniques such as standardization and log transformation to standardize the data or to apply log transformation for the data. Good techniques from scikit-learn, it includes, for example, standard scaler, power transformer, or robust scaler. Next, in the feature engineering topic, we're going to talk about how to treat categories and text data. So the ML algorithms expect the data in proper format, and this format, it entails having the data in a numeric representation or create like a numeric embeddings or numeric format for the data. So if we have like a data and one of the columns would be, for example, people relates to different classes, and these classes could be high, medium, low. So I need to think of a strategy to convert this category, which is high, medium, low, into numeric. And for this, we use categorical encoding, and which entails like transforming categorical data into some new representation, which is numeric, required by the model. And there are various approaches which we can use in this context, such as one-hot encoding, label encoding, or ordinal encoding in case we have ordinal data or data with specific order. Also, if we are dealing with text data, so we also need to think of a strategy to convert, to transform the text data into numeric embeddings or representation. And there are different techniques also that could be used in this context, such as TF-IDF, which stands for term frequency inverse document frequency, or count vectorizer, or GLOVE, which is like a ML algorithm stands for global vectors for word representation. And what does these do, like TF-IDF or count vectorizer or GLOVE? They take the text data and they transform it into numeric representation, which is accepted by the model. The next feature engineering technique that we're gonna cover is called data shuffling. And with data shuffling, it's a highly needed step in data processing and model training, and which simply helps us to randomly reorder or resample the instances or observation in data set, which helps reduce biases and improve model generalization. We're going to talk about AWS QuickSight. We did cover this in our previous video, but here, like, we're going to talk about from ADA perspective. AWS QuickSight is a visualization tool, which is serverless, fast, easy, cloud-powered business analytics service for data visualization. It has an important feature where data sets are imported into Spice. which stands for super fast parallel in-memory calculation engine. It's worth noting that we have some ML capabilities in QuickSight, and these ML capabilities helps us to identify or to detect anomalies or anomaly detection. It helps us to do forecasting, and it helps us to do automatic generation of narratives. These are the ML capabilities in QuickSight: anomaly detection, forecasting, and automatic generation of narratives. AWS Athena simply allows users to use SQL to access data directly on S3 without moving the data out of S3. So if we are saving data like any Parquet format, CSV or whatever to S3, we can use Athena to query this data and to extract specific relevant rows and columns, or even perform SQL-based transformation and aggregations while the data is sitting on S3 without the need to move it from there. The next topic that we're going to talk about is AWS Ground Truth, and it's a labeling service which helps us create high quality label training data sets for ML models, because one of the biggest challenges of doing ML with unstructured data, for example, or with unstructured data such as text or images, is that we have high quality, but it's unlabeled data, and we need some sort of labeling data in order to do or to solve some ML problems. And AWS Ground Truth helps solve this problem, which creates high quality labeling training data set for us. Labeling can be done by three options. First option is Amazon Mechanical Turk, which is like AWS stuff, or we can use our internal team to label the data within the AWS Ground Truth platform, or we can hire professional labeling companies to do the labeling for us. So one important feature of Ground Truth as well, Ground Truth can create its own model for labeling. So as images, for example, or text are labeled by people, the model would learn how the labeling would work, and only, for example, images or text the model isn't confident about would send to human labelers. So this takes us to the end of the content or the main topics of the exploratory data analysis section. I hope you find it useful, and now we will start tackling some of the questions which help us test the content that we just covered, and also gives us a taste of the real exam questions related to the ADA section. So, as covered in the previous video, the first strategy is for us to read the question, look for keywords, and think of potential solutions that would help us solve the scenario without going to the given choices. And then we look into the given choices and we select the best correct one. So if you look at question number 1, they are telling us you are a data scientist and you are creating a binary classification model to predict whether a customer will leave the company or not. So this is a churn problem. And during the exploratory work, you realize that the account tenure with some missing values. So the account tenure is a numeric variable, and it has some missing values. This variable is expressed in real numbers. What would be the fastest approach to dealing with missing values, assuming you don't want to lose information? So the key words here, it could be that we have the account tenure, it has missing values, it's expressed in real numbers, which is numeric, and what's the fastest approach? So they are telling us to the fastest approach. So if we go back to what we discussed in the previous slides, when we have missing values, we could think of 4 main approaches. We could think of dropping the rows, which is the least favorable approach. We could think of replacing median or mean. Median is better when we have outliers. We can think of USKNN, or we can think of developing a regression model, which help us to to study the relationship between account year and other features. These are the four potential solutions. They're asking us for the fastest approach. So they're telling us option A to drop the missing values, which is least favorable and not recommended. Option B, create a regression model to predict the account year and use it to predict the missing data. It could be, but this is more advanced solution. Create a deep learning model to predict the account year and use it to predict the missing data. As we discussed earlier, deep learning model works better for categorical data, and it's more advanced solution. And option D, replacing the missing data with the mean or median value of the variable. So in this scenario, we'll definitely go for option D because it's the fastest approach and it helps us to retain the data that we have and to treat the missing values. So we could either replace with median or mean. If, for example, they did mention that the data has outliers, then we should only choose median. They could like split the options into like D and E. D is for median, E for mean. Then we have to choose the option which expresses median because median is better to be used when we have skewness or outliers in the data. Question number 2, they are telling us you are working on a project to identify solar panels on roofs from footage data. Currently, the business doesn't have much labeled data. What AWS solution would you recommend to generate labeled data? So we did discuss also that. So we could think of AWS Ground Truth, which help us to create high quality labeled training data sets. And if we look into the options here, we have AWS Data Wrangler, AWS Augmented AI, AWS QuickSight, and AWS Ground Truth. And we should choose option D, which is the labeling service available in the AWS. Question number 3. They are telling us you are a data scientist working on a fraud detection problem. You notice that the number of fraudulent examples in your data set is extremely small. What are some techniques you can apply to mitigate this? Choose all that apply. So key problems here, keywords we should look into is number of fraudulent example is extremely low, so we have imbalanced data set. And what are the techniques that you can apply to mitigate this? We did also cover that, so we could think of upsampling the minority class, which is the fraudulent class in this scenario. We could think of undersampling the majority class, which is the non-fraudulent class in this scenario. We could use other techniques such as SMOT to generate more synthetic attributes for the minority class, such as fraudulent class. Or we can play with the thresholds in order to help the model to identify fraudulent examples more easily. So if we look on the solutions, onto the options that are available, option A, it could be to write a custom loss function that penalizes the model for incorrectly predicting fraudulent examples. It's the same like playing with the thresholds in order to help the model to identify fraudulent examples easily. B, to perform SMOT upsampling on the fraudulent class, which is the minority class in this example. C, it could be to upsample the fraudulent class. Or D, simply drop the minority class since you have too few examples and the model will not be able to learn from them. So option A is definitely correct. Option B is correct. Option C is correct. Option D is definitely incorrect because if we drop the minority class, then we will end up with one class only, and this is not a binary classification or fraud detection problem, so we'll not be able to deliver the project. So A, B, and C are the correct answers. Question 4, telling us which of the following is valid data engineering strategy. Option A is to split the data set into train test, standardized training set, use the mean standardization or standard deviation to standardize the data set, then train the model on training and make prediction the test set. So Or option B, it could be to standardize entire data set, split standardized data set into train set, train model on the training data, and make prediction data set. Option C is to split the data into train test, convert categorical values in the training set, and then train the model on the training data and make prediction of the test set. So before training the model, we should think of steps in order to prepare the data. And one of these steps is like to think of splitting the data set into train and test. And when we split the data set into train and test, also we need to, for example, think of standardizing the training data set. But the same standardization process that we apply for training data set, we should consider applying it on the test set in order to help the model to predict on the test set. Otherwise, it will throw an error. And then we should think of training the model on the training data set and make predictions test set. So strategy A is option A is definitely correct because it's splitting the data into train tests is correct. We standardize the training data set and then we apply the standardization using the mean or standard deviation to standardize the test set. Then if we ask the model to predict on the test set, it will not throw an error. Whereas if we look at option B, we shouldn't think of standardizing the entire data set because train set and test set should be treated separately. So option B is wrong. Option C, it's good that we are splitting the data set into train and test, but it's only converting categorical values in the training data set using one hot encoder. And if we do that, and then we ask the model to predict on the test set, this will give us an error because the model is expecting also the categorical values of test set to be featured engineered to be numeric as well. So we should apply one hot encoder for the train set and the test set separately. And then when we ask the model to predict on the test set, then it will not throw an error. So in this case, option A is the correct answer. Question 5, they are telling us an ML specialist is creating a new NLP application that processes a data set. The aim is to then run word2vec to generate embeddings and enable different types of predictions. Here's an example from the data set. The quick brown fox jumps over the lazy dog. So we could see like like for example, a mistakes written here as quick should be like with an I. So, and some of them are capitalized, some of them is not capitalized. So they are telling us which of the following are the operation the specialist needs to perform to correctly sanitize and prepare the data in a repeatable manner. Choose 3. Option A, it's to perform part of speech tagging and keep the action and verb and the nouns only. So we can perform part of speech tagging and like determine which of them are verbs, nouns, subjects, but we cannot only like keep the verbs and nouns because this will let us lose another valuable data as well. Option B, to normalize all words by making sentence lowercase. Yep, this is very variable approach. We can make it using word.lower. C, to remove stop words using an English stop word dictionary. Also, this is a needed step. We can, for example, use the stop words package from an LTK library in order to perform that. Option D, correct the typography on quick to quick. This is like unreasonable to do it because this is only a sentence, but we could have like 10,000 sentences and it's unreasonable to correct each sentence separately. Option E, to use one hot encoder on words in the sentence. This is like also unuseful because because we have different potential combinations between if we gonna like one hot encode each of these words. And option F, to tokenize the sentences into words, and also this is like very needed processing step in NLP work, and we can use the word tokenize package from we can use the word tokenize package also from an LTK library, which helps us to tokenize data set. So out of these 6 options, we could choose definitely option B, which is to normalize or make words lowercase. Option C, we should definitely remove stop words or like unrepetitive, unneeded, repetitive, common English words. And definitely we should think of option F, which is tokenize the sentence into words. And this brings up like B, C, and F are the correct answers. So this takes us for the end of this video where we did explain the main content of the EDA section of the AWS ML examination. And as I said in the previous video, this only gives you an overview of the main topics, but you should read more and dig deeper into each of the topics we talked about. How to use it, where to use it, and why to use it as well. There are like a bunch of resources available online. And the next video which I'll be releasing will be about the modeling section, which will be the biggest and the most important section of the examination. Until then, happy studying. And today we'll be covering the third exam section, which is about modeling. And it's the biggest and the most important section, which weighs around 36% out of the whole exam. So this section, it focuses on basic data science topics that I believe everyone who has been working in the field, they should know about. So we're gonna aim to review like basic topics and build on that in order to go into advanced topics on this section, which is mainly about AWS SageMaker, which constitutes around half of this section, and you should expect to have lots of questions around SageMaker, built-in algorithms, etc. So as a description of this section, it focuses on model selection and evaluation, training and fine-tuning models, model deployment and monitoring, and model optimization. It also tackles various ML algorithms and other services available in Amazon SageMaker for model training and deployment. So it's like as I said, it's the most important section and has a lot to do with model development, training, fine-tuning, and deployment using AWS SageMaker. So the strategy is as before, is to cover the main content, and then we're gonna end up with sample questions which help us to test our knowledge and to give us a taste of real exam questions. The main topics that will be covered in this section can be summarized in this slide. We're gonna start to talk about the end-to-end machine learning cycle. Then we're gonna review the types of machine learning solutions, supervised, unsupervised, and deep learning. Then we're gonna spend some time talking about machine learning performance matrix. And then we're gonna move into AWS SageMaker, where we're gonna give an overview of AWS SageMaker architecture and features. And then we're gonna talk in depth about AWS built-in algorithms and what are the options for training, deployment, and hyperparameter optimization in SageMaker. And we're gonna end with AWS Autopilot and Canvas solutions or services, which are also available as part of SageMaker. The first topic that we're going to talk about is end-to-end machine learning cycle. So this graph, it summarizes the different stages that almost, I would say, every machine learning project goes through. So first of all, we start with the business goal, which is what we are trying to achieve out of this project. So after we have the business goal, then we take the goal and we frame it in ML problem, which is like, are we trying to solve classification problem, regression problem? This is what we mean by ML problem framing. And then after we frame the problem, then we gather the data and we start doing data processing. And after we do the data processing, we can start developing the model. But sometimes when you develop the model, you discover that you need more data, or you need to further work on processing, on transforming the data. So you need to go back to data processing and then go back to model development. And then after model development, and when we have a model in place and we did evaluate the performance of this model and we are fine with it, we move to the second stage, which is model deployment. And after model deployment, we're gonna think of monitoring techniques in order to monitor this model when it runs in batch or in real time in order to make sure it's giving reasonable and accurate predictions. And after we have the monitoring, sometimes you go back to model development in order to refine the model, deploy it again, and have monitoring results. So as you see, these steps are not like one-way steps. Sometimes you will be doing model development and then you need to go back to the processing, and sometimes you are doing monitoring and then after the monitoring you need to further refine and develop the model. So within each step, you will be thinking of the previous steps and how to improve the model performance in order to enhance the achievement of the business goal. So you need to go back and forth in order to make sure that your project is going on the right way and you are solving the problem that your client or your stakeholder has communicated for you. So just to sum it up, first of all, you start with your business goal that you aim to achieve. Is it like to increase sales by 5% or to decrease the amount of fraudulent activity by 10%? This is like what's the impact will be on the company or in the business activity. Then you take this business goal, you transform it into ML problem, and then you start to gather data, process the data, build the model, evaluate the model, and when you are fine with the model development, you move to deployment to take it to the end user. And after deployment, you need to think of monitoring or evaluation mechanisms in order to make sure that the model predictions are accurate and reasonable. So, what are the types of machine learning solutions? It could be summarized into below. We have supervised learning, unsupervised learning, and reinforcement learning. And I'm pretty confident that every data scientist who has some experience, they would know the content that we're gonna cover in this slide and in the upcoming slide. But it's also good to give a refresher and make sure that everyone has the necessary foundation before we go into the advanced topics of AWS SageMaker. So the types of machine learning solutions, it could be summarized as below: supervised, unsupervised, and reinforcement learning. Supervised learning is a type of ML where the algorithm is trained on a labeled data set to predict continuous variables such as regression, or to predict categorical variable when we talk about binary classification or multi-class classification. So supervised, you need to know that supervised, when you have labeled data set, you have a labeled target variable, and if it's continuous, so if you are predicting, for example, the amount of sales for next year, we are talking about regression, or if you are predicting the customer type, or if you are predicting if this customer will churn, yes or no, this would be binary classification. Or if you are predicting the category of customer review, this would be multi-class classification. The second solution would be unsupervised learning. And for unsupervised learning is when the algorithm is trained on unlabeled data set. So you don't have a labeled target variable, and you use this unlabeled data set to find patterns, clusters, or relationships. Examples include clustering and dimensionality reduction. And the third ML solution is the reinforcement learning, and it's when an agent learns to make decisions in an environment to maximize a cumulative reward over time. So these are the three main types of ML solutions. We're going to talk a bit further about it. So within the supervised learning, we said we have regression, and regression is used when you want to predict continuous variables. Some examples include, such as given values advertising spend, predict the sales for next year. This is a regression problem. Uh, Second example could be given characteristics of the couple, predict the matching probability, such as, and this is like a recommendation system in dating apps. This is also a regression problem. On the other hand, we have classification, and classification is used to predict categorical variables. As I said earlier, we have binary class when you have two classes, like true or false, versus multi-class classification, you have when you have more than two classes. And examples could include, for example, detect fraudulent activity in credit card transactions. Here we are detecting if it's fraudulent or non-fraudulent, so this is binary class classification. Or if you want to classify customer reviews into various groups, such as payments, complaints, inquiry, billing, customer experience, and could be a multi-class classification problem. So for unsupervised learning, as we said earlier, we are training an algorithm on unlabeled data set. Examples could be clustering or dimensionality reduction. Clustering is used when we want to find subgroups or structure information and derive meaningful relationships from data. Examples could be when we want to do customer segmentation and segment customers into groups with similar preferences in order to be targeted with tailored marketing, for example. And another example could be to identify topics in a set of blog posts and to know also what customers will be talking about. For example, a new launched product, talking about customer experience, etc. And another type of unsupervised learning is dimensionality reduction. And dimensionality reduction is a commonly used approach in feature processing to remove noise from data. When you have like a huge amount of data and you want to like reduce the dimensions of this data, but at the same time retain the information that is available in this data set, you can apply dimensionality reduction, where you transform high dimensional customer data into a lower dimensional representation that still captures the essential patterns and variations that you want in order to train machine learning algorithm. Reinforcement learning, as I said, it's used like to develop a learning system, okay, which is called an agent in this context. And this agent will observe the environment, will select and perform actions, and get rewards or penalties in returns, depends on the outcome of the action. So a very popular, successful reinforcement example would be the DeepMind's AlphaGo program, which was developed in March 2016, and where this program, the AlphaGo program, did beat the world champion and at the game of Go, and where what happened there, it's like this program or reinforcement program, AlphaGo program, it did learn the winning policy by analyzing millions of games, and when this program did play against the champion, it ended up like winning the game against him. And the thing is, or the key here is like this learning system or this agent is learning the actions by going, and as we give it more rewards, he would know that it's doing the right action, and if we give it penalties, he would know that we are giving it's doing like a inappropriate or the wrong action, and it will give it negative rewards. So this is how it learns. It learns by itself, but also by giving it rewards or penalties in returns. So this is a summary table of ML types. We said we have supervised, unsupervised reinforcement learning. Within supervised, we have labeled data, and we are predicting outcome or future. We also said we have regression and classification. For unsupervised learning, we are talking about unlabeled data set, which doesn't have targets, and it's used to find hidden structure in data, such as clustering or dimensionality reduction. And the third ML type is reinforcement learning, where it could be considered as decision process or reward system, where it learns series of actions based on awares or penalties. The second topic that we're going to talk about is deep neural networks, and like deep learning has gained a lot of attention in the previous years, and it's developed to design and simulate the behavior of human brains, interconnected network of neurons. So just like it tries to model or replicate how the brain would work, we do it with neural networks, and it becomes so popular in the previous years because of the high generation of data, because we have huge availability of data, which would make deep neural networks more successful. And the second success factor would be the high availability of computational power, because these deep neural networks, in order to be trained, it needs high computational power. So if we cover a bit about the deep learning components, we can see that DNNs have multiple hidden layers between the input and the output layers, which gives them the ability to learn the representations of data in a more complex way. So each layer, where increasingly abstract features or concepts, so it will learn more, allowing the network to capture complex patterns and relationships where classic machine learning might fail. So this is why we use deep neural networks. Deep neural networks have something which we call activation functions, and these activation functions, it defines the output of a neuron given its input signals. So it's good to know that in case of binary classification, we have sigmoid activation function, and in case of multi-class classification, we would have softmax activation function. So sigmoid is activation function used in case of binary classification, and softmax is an activation function used in case of multi-class classification. There are different deep learning architectures that everyone should be aware of, such as CNNs or convolutional neural networks, and which is used for image and video processing, such as image classification. We have RNNs or recurrent neural networks, and which is used for sequence data processing, such as machine translation. And we also have JNs or generative advisor networks, which is being used for generating new data examples. So some of the modern deep learning architectures are CNNs, RNNs, and JNs. Some important concepts also in the context of deep learning, we have learning rate and batch size, and these are like hyperparameters. Learning rate is the hyperparameter that determines the step size of weight updates during optimization in model training, whereas batch size is another hyperparameter that defines the number of training samples used in each iteration of the optimization algorithm during model training. So learning rate and batch size, in other words, are hyperparameters that control the model training process. Important details that we should know about these two hyperparameters. We should know that small batch sizes are good to prevent not converging the problem in the wrong solution, because if we use large batch sizes, we can converge the model in the wrong solution and it gets stuck in the local minima. On the other hand, large learning rates, if we use large learning rates, can overshoot the correct solution, and which oscillates and miss outliers. Whereas small learning rates are better, but at the same time, they increase training time, or it takes more time for the model to be trained. So as a rule, we should opt for low learning rates and or small batch size while defining these hyperparameters in the model training process. So we should aim for low learning rate and small batch size when defining the parameters, when defining the hyperparameters in the model training process. Some techniques to apply regularization or to control overfitting, because sometimes overfitting means when we train a model and the model performs very good on the training set, but it fails to perform well on the test set. So the performance would be so different between train set and test set, and this is what we call overfitting. And in order to control overfitting in the context of deep learning, we can think of the below 4 strategies. First of all, to apply dropout, or to apply early stopping, or to apply L1, which stands for lasso, and it's sum of weights. And lasso, it's good to know that it's used for feature selection, because what does lasso do? It brings some variables to 0. And the fourth technique would be to apply ridge, or L2, and it is the sum of square of weights, which reduces the impact of less important features, but it doesn't bring some variables to 0. So the main difference between L1 and L2, L1, it's used for feature selection because it brings some non-important variables to 0, whereas L2, it keeps all variables or all features, but it assigns weights, which are not 0, unlike L1, okay? The next topic that we're going to talk about is machine learning performance matrix. So we have different performance matrix which differ between ML solutions if we're talking about regression or classification. But if we're talking about classification, we can think of a confusion matrix, which is simply a table that summarizes the performance of a classification model by comparing predicted and actual class labels. Within the context of confusion matrix, we can think also of precision, which helps to evaluate the assertiveness of correct positives. And precision can be computed as true positive divided by true positive plus false positive. Recall, and which is known as sensitivity or true positive rate, it gives the importance, or it provides an insight about the importance for real positive cases. And it can be computed as follows: true positive divided by true positive plus false negative. Another performance metric which you should know about is F1 score, and F1 score is used when we want to take into consideration the assertiveness of both positive and negative classes. It's known to be as harmonic mean of precision and recall, and it's calculated as follows. It's 2 multiplied by precision and recall divided by the sum of precision and recall. And for the exam, you should know what each of these performance measures do, and you should know how to calculate as well, because they might give you a question to calculate F1 score, they might give you confusion matrix and ask you to calculate F1 score or recall or precision. So the question that we should ask ourselves: who want to use precision or who want to use recall? So we should use precision, or we should choose precision as our ML performance metric when we want the prediction of positive classes to be correct as possible as we can. Examples or business examples could be, if we are applying YouTube recommendations, we should use precision. If we are applying a model to predict the criminal death punishment or spam detection or loan applications, in these examples, we should aim to use precision. On the other hand, we should aim to use recall when we want our model to spot as many real positive classes as possible. So when we want to reduce false negative, in other words, we should aim to use recall, such as if we're developing a model to predict cancer or to detect cancer, then in this case we should aim for recall, because we want as many as real positive cases to be detected by the model. Fraud detection, another example, or if we are developing a model to detect unsafe work images as well, because this affects people's life, then we should also aim for recall. The two other ML performance metrics that we should know about are ROC and AUC. And ROC stands for Receiver Operating Characteristic Curve. And it's a plot of true positive rate, which is the recall, versus the false positive rate at various threshold settings. Ideal curve of ROC would be a point in the upper left corner. And ROC is better used when both outcomes have equal importance. So if the question entails that both outcomes or both classes have equal importance, then we should think of using or choosing ROC. AUC, on the other hand, it's the area under the ROC curve. It's equal to the probability that a classifier will rank a randomly chosen positive instance higher than a randomly chosen negative one. So if we have AUC of 1, this means we have perfect classifier, and I doubt someone will get there. 0.5 means we have useless classifier because it has the same probability of choosing positive or negative, which doesn't make sense. And AUC is best used in case of imbalanced class distribution. So if we have a data set with classes which are imbalanced, then we should think of using AUC. So this takes us into the end of covering the basic ML concepts, which ML performance matrix, what are the types of ML solutions, and now we'll start talking about AWS SageMaker. And AWS SageMaker is a fully managed machine learning service that's available in AWS platform, and that developers and data scientists can use to build, train, and deploy models. So it's one service or platform which helps to do end-to-end ML project, from building the data set, doing pre-processing, training a model, and fine-tuning the model, and then deploying the model. It's all available in SageMaker. And as we see in the upcoming slides, we have features which cover all the ML project cycles. So if you want to give like a brief overview of what SageMaker is about, SageMaker helps us to fetch, clean, and prepare data. So this is the first step of ML project. Then it helps us to train and evaluate a model, which is training and fine-tuning. And then we can deploy the model, evaluate results in production. So as I said, it can cover almost all the project cycles, from fetching, cleaning data, processing, and transformation as well. Then to move into choosing ML algorithm, training the model, evaluating the model using proper ML performance matrix. Then when we want to deploy the model, bring it to production and bring it to the end user, also we can evaluate the model in this stage, and then we can also repeat the same exercise in order to keep refining and improving the model that we have in production. So what's the SageMaker architecture? Here we see that SageMaker, it uses S3 and ECR, which stands for Elastic Container Registry. So we see that the model training and the model hosting, it's being done within SageMaker, but we also use S3 to load S3 model to load the model artifacts. For example, if we are using a model or using like AWS built-in algorithm, we can load the artifacts or the model artifact from S3, and we also can load the training data from S3. So S3 is used to load the model artifacts and to load the training data or the testing data. And then we do the model training within SageMaker. And we also need the training code image, which also being loaded from ECR or Elastic Container Registry. And then after we do the model training, we evaluate it and we are good, we are ready to deploy the model or to host the model. And for model hosting, we need the model artifacts from S3, which are the artifacts of the trained model. And we need the inference code image, which also being loaded from ECR. We host the model within S3. We create an endpoint if we are talking about real-time prediction, which is being loaded for client app to the end user at the end. So to emphasize on some points, so we need to know that S3 is being used to host or to save the artifacts of the trained model. It's being used to save training data as data. We load the training data from S3. We do the training on SageMaker, and we load the trained model artifacts from S3 and the inference code from ECR. We do the model hosting within SageMaker, and then we create the endpoint. So what do we need from S3? We need the model artifacts and training data. And what do we need from ECR? We need the training code image and the inference code image. And the model training and the model hosting and the endpoint are being created and hosted within SageMaker. So, as I said earlier, so SageMaker includes features which are relevant to the different phases of machine learning. So if we are talking about data preparation or processing, we can think of ground truth, data wrangler, processing, feature store, and clarify. If we're talking about building the model, we have tools such as notebooks, Studio, Autopilot, Jumpstart. If we're talking about training and fine-tuning the model, we have managed trainings, experiments, tuning, debugger. And when we want to deploy the model, we have managed endpoints, model monitor, pipelines. So probably will not have time to discuss all of these topics, but what I do advise you is like to go to AWS SageMaker documentation and try to know what each of these features do and when to use it, in which phase of the machine learning and how to use it, okay? So, some of the topics that we're going to talk about are definitely notebook instances. And notebook instances are managed machine learning compute instance, which EC2 instance, which runs on Jupyter server. It has access to S3 if you want to load the training data, test data, or if you want to save the model artifact at the end, or if you want to save the preprocessed data, if you are doing data processing. So it has access to S3. We can use scikit-learn, Spark, or TensorFlow within these notebook instances. It has wide variety of built-in models, which we're going to talk about in a bit. It has the ability to spin up training instances of our choice, and has the ability to deploy trained models for making predictions at scale. So this is what notebook instances SageMakers do. To create your notebook instance, these are the things that you need to think about while creating your notebook instance. You should think about the EC2 instance, which is being spun by virtual machine, and you need to choose which family this EC2 instance should belong to. And within that, you have TMCP. C stands for compute optimized, and P stands for GPU. So if you want to train like a deep learning model, which has like million or billion of parameters, then you have to go for GPU. If you are training like a regular algorithm, you can go for C, compute optimized. And then, other than the family of this EC2 instance, you should think of its size. You have medium or X large, and you have like medium, large, X large. You need to choose, and you have to choose the right version of the EC2 instance, and which is like ML.T3. You have T4, T5. It depends. So, while choosing the EC2 instance, you should think of the family, size, and the right version. You also need to think of the EBS volume to store data, and it can be ranged between 5 gigabytes, which is the default one, and 16 terabytes. You also have the option to do something which we call lifecycle configuration, and it's simply a bash script which you can develop in order to create or start a notebook and to make notebook to run at a specific time and to install some packages. So lifecycle configuration helps you to create, start and run a notebook using a bash script, and it also helps you to install packages which are needed to run this notebook. The last thing is the elastic inference if you want to attach it to the notebook instance, and elastic inference allows you to attach low-cost GPU to SageMaker instances in order to reduce the cost of running inference. So these are the things that you need to know while creating your notebook instance. You need to know what family, size, and version of the EC2 instance you want to use to spin by virtual machine. What's the EBS volume? If you want to use lifecycle configuration, and if you want to attach elastic inference. SageMaker Studio, we can think of it as like web-based IDE for machine learning, which has Jupyter Lab environment. Within the SageMaker Studio, you have the visual git workflow. You have the option to do experiment tracking if you are testing different models. Within SageMaker Studio, you also have SageMaker Autopilot, which we're going to talk about later in the video, which is used for AutoML on tabular data sets. You also have something which we call SageMaker Jumpstart, and within SageMaker Jumpstart, you can have like curated one-click solutions for applications without ML knowledge. You can have building pipelines. You can use Clarify, SageMaker Clarify, which is used for detecting pre-training bias. You can have feature store to help you create, share, and manage data, and you can have data wrangler to prepare the data. So these are all the features which are available in SageMaker Studio. IDE, web-based IDE, Jupyter Lab, Git workflow, experiment tracking, autopilot, jumpstart. I also advise you to go and read the documentation of SageMaker Studio and see what are the available features there and what does each feature help for. Okay, now we're going to talk about the built-in algorithms of AWS SageMaker, which is also a very important topic for the examination. But before going there, let's reiterate some concepts of the end-to-end ML cycle, and then try to break down the machine learning problem. So to break down the machine learning problem, I would say the most important step is to know the use case or the business goal, what we are trying to achieve here. For example, are we trying to achieve fraud detection? After we determine the business goal or the use case, then we need to look into what data do I have. Do I have structured data, numeric, continuous, or do I have unstructured text data? After I navigate or explore the data options I have, then I go to option number 3, which to choose which model should I use, or which ML solution should I follow. Should I follow supervised, unsupervised, or deep learning? After I determine which model or which ML solution should I take, then I can frame the problem to use models I know. So how do I frame the problems? Should I use regression, classification, clustering, or reinforcement learning? So to break it down, first of all, you need to know what's the use case of the project that you are working on. What are the available data you have? Which ML solution or which model should you use? And after that, you need to frame the problem in a way that you can apply ML. In this slide, I'm just like summarizing all the built-in algorithms of AWS SageMaker. Each model solves prediction problem. And I do advise you also to go into the AWS SageMaker documentation and to go over all the available algorithms that are being developed, because this list might be extended in the future. But if we go for classification, for example, you need to know that the most prominent built-in algorithms for classification are linear learner, XGBoost, KNN, and factorization machines. If we are talking about computer vision, we have image classification model, object detection, and semantic segmentation. If we're talking about topic modeling, you have LDA and NTM. For forecasting, you have deep AR. For recommendation, you have factorization machines. If you are working with text, you can think of blazing text algorithm. For regression, you have linear learner XGBoost. And for sequence translation, you have sequence to sequence. And for clustering, you have k-means and KNN. So the prediction problems could be computer vision, recommendation, forecasting, regression, etc. And for each prediction problem, you have different algorithms that you can use. We're gonna talk a bit about some of these algorithms, but as I said earlier, I advise you to go into the AWS SageMaker documentation and to look into each of the algorithms, to read the documentation of each of the algorithms that are available, and you need to know what's the use case of this algorithm, what kind of preprocessing is needed before using this algorithm, what are the main hyperparameters of this algorithm, and how to train this algorithm. So 4 things which I advise you to know ahead of time. Is the use case of the algorithm? Is there any processing needed for the training data in order to use the algorithm? What are the most hyperparameters which boost the performance of this algorithm? And is there any special consideration that we need to know for training? Does it need CPU or GPU? So linear learner. Linear learner is an algorithm which is used in either regression or classification, and it's like resample, or like it reflects the way that simple regression would work, and which is to fit in line to your training data. For linear learners, you should normalize the data. So normalizing is an important preprocessing step before using linear learner. So you need to make sure all the features are weighted the same. The most important hyperparameters of linear learner is balanced multi-class weights, learning rate, many batch size, L1, and weight decay. And this is only like some of the hyperparameters. Like there are others. I also advise you to go and to read what does each of these hyperparameters stand for. And for training the linear learner, you can either use single or multi-machine CPU or GPU. Depends on the amount of data or the volume of data you have. The other algorithm that we're going to talk about is sequence to sequence, or like if you have input-output sequence of tokens. The use cases of this algorithm is machine translation, text summarization, or if you are developing speech-text solution. Framework, it's implemented with RNNs and CNNs with attention, and it uses pre-trained model like BART or T5. The most important hyperparameters of sequence to sequence are batch size, learning rate, and you can optimize on accuracy, BLEU, or perplexity. For training this model, of course, you need to use GPU instances. You can use P3, for example. DeepAR, it's used for time series forecasting, and it helps us to find frequencies and seasonality in the data. The framework is simply you need to include the entire time series for training, testing, and inference, and you can train on multiple time series. This is the one uniqueness of DeepAR, which helps you to train on different or multiple time series. The most important hyperparameters of DeepAR are context length and prediction length. Context length is the duration of time you need to look into in the past, and prediction length, how many days or weeks you want the model to predict for the future. Epochs, learning rate, and many batch size are the other important hyperparameters. And for training, you can either use CPU or GPU. The next built-in algorithm that we're going to talk about is blazing text, which is used for text classification and word-to-vec. And it helps to predict labels for a sentence or create a vector representation of words for translation or sentiment. The framework, the word-to-vec one, it has multiple modes, which are CBOO, or continuous bag of words, or skipgram. The hyperparameters are being used for text classification are epochs, learning rate, and word engrams. And for training the blazing text, for text classification, CPU is recommended, but if you are implementing the word-to-vec solution, then GPU is better. So I also advise you, go to the blazing text documentation, know what are the most important hyperparameters, what's the difference between word-to-vec and the text classification modes, and how to train this model. Factorization machine, which is used for recommendations, and the use cases of factorization machine is when we have sparse data. So whenever you see a question which entails sparse data, then you need to think of factorization machine. Popular business examples could be like to-click prediction and item recommendations. The framework of factorization machine is like when we have, or when given a matrix representing some pair users and items, to predict the click or not to click, or to predict like a rating of given products for a customer, what's the most popular or what's the prominent fancy product that we should advertise or give it to the customers. This is being done by recommendation engines, and which could employ factorization machines. The most important hyperparameters factorization machines are number of factors and feature dimension. And for training factorization machine, because we have sparse data, we can think of CPU. So here I'm adding a summary of the built-in algorithms use cases. But also you have like a very extended summary on the AWS website or AWS documentation, which tells for each algorithm what are the best use cases. So if we have a use case to predict if an item belongs to a category, for example, spam detection, we could think of linear learner, XGBoost, factorization machine, k-nearest neighbors. If we are thinking of a use case to predict a numeric or continuous value, such as estimate the value of a house, we can also think of linear learner, which is being used for regression classification, XGBoost, which also used for regression classification. We can think of factorization machine, which also being used for regression classification, and k-nearest neighbors. If you see, these 5 models can be used for regression and classification: linear learner, XGBoost, factorization machine, and KNN. If we have a use case to predict future behavior, like time series, or to predict sales on a new product based on previous sales data, we can think of DeepAR. If we have a use case to identify duplicate support tickets or find the correct routing based on similarity, we can think of object-to-vec algorithm. And if we have a use case, for example, to tag every pixel of an image individually with a category, we can think of semantic segmentation algorithm, which can help us to determine or to tag every pixel of an image individually with a certain category. So yeah, these are the main use cases, but you need to know for each use case what kind of algorithms, or the way around, for each algorithm you need to know what are the potential business use cases that you can apply for. The next topic is we're going to talk about is what are the training options in AWS SageMaker. And the training options could be summarized as using an algorithm which provided by SageMaker, like AWS built-in algorithm. We can use Apache Spark with SageMaker, or we can submit a custom code to train at SageMaker, or we can use our own custom algorithm with a Docker image, or we can use an algorithm from AWS Marketplace. So here I also advise you to go to AWS SageMaker documentation and to read thoroughly about each of these training options. What are the differences and what are the steps needed, for example, to train your custom code in SageMaker, or what needed steps to use Apache Spark or MLlib within SageMaker. I would say the easiest one is to use an algorithm provided by SageMaker, which is simply loading the container of the model and then seeing what are the needed data processing, which should be followed before using the algorithm, and then ask the model to, or ask the algorithm to be trained on your data. Next, we're going to talk about deployment options on SageMaker, and with deployment options, we have two modes, which are endpoints and batch. For endpoints, endpoints are used as persistent endpoint for making individual predictions on demand. So if we're talking about predictions on real time, we should think of endpoints. And for endpoints, we can use multiple EC2 instances, with each instance have model artifacts and responding to requests from RESTful APIs. It's perfectly used for online referencing or real-time predictions. And the method to do it, you can create an endpoint and then call this endpoint.predict on whatever ask you have. And you can also use automatic scaling. So as the data or as the requests increase, you can use more compute instances. Second deployment option is batch transform. And batch transform, we use it when we want to get predictions for an entire data set. And when we want to run inference which doesn't need a persistent endpoint. So if it's not run, if it's not endpoint, we can use batch transform, and we can use the lambda function to execute the code and start the batch transformer job on the entire data set. And the method to do it is we create a batch transformer job, which is called transformer, and we do transformer to transform in order to transform the data set and create predictions. The next topic we're going to talk about is hyperparameter tuning. And for hyperparameter tuning on AWS SageMaker, we can use random search and Bayesian optimization search. The first step you need to do is to split the data into train, validation, and test data sets. And this hyperparameter tuning, it allows us to find the best values, for example, for some of the hyperparameters, such as learning rate, batch size, or depth. We did cover this before. Learning rate is a hyperparameter that determines the step size at each iteration, and batch size determines the number of samples processed before the model is updated. And we use hyperparameter tuning to test every combination of every possible value somehow, then train a model and evaluate it every time and give us the best results. So it gives us the best results of the hyperparameters, which give the optimal model performance. So for hyperparameter tuning, we need to define the hyperparameters and ranges. We need to pick objective metric and strategy, and we need to set up the job parameters. Here we're giving an example, and some of the tips for hyperparameter tuning: we shouldn't optimize too many hyperparameters at once. We should limit our ranges that we need to search for, and it's better to use logarithmic scales. And I forgot to mention that, but the two hyperparameter tuning approaches available in AWS are random search, and Bayesian optimization search. Ground truth, we did talk about this in the first in the ADA section in the second video, which is labeling service. It manages the humans who will label data for us for training purposes. And within ground truth, we can create our own model. And as the model learns more, only data points that the model is not confident about can be sent to human labelers, which can reduce the cost for us, the cost of labeling. And who can label? Mechanical Turk, AWS staff, or we can invite our internal team to do the labeling for us within the ground truth platform, or we can hire professional labeling companies to do the labeling for us. Autopilot is an AWS SageMaker feature which helps us to do AutoML, but with guidance and judgment, where we can give it raw data, which should be tabular data from Amazon S3. We select the target column for prediction, and then Autopilot will do automatic model creation for us, which will give us correct algorithm to use. Training and tuning is done automatically for the right model. We don't need to do the model tuning by ourselves. And also we have full visibility with model notebooks. So it will create the notebooks for us, the fine-tuning script, etc. But we'll be able to see how this model is, how this notebook is being developed, and we can amend it and then deploy it again and monitor the model. Whereas Canvas, on the other hand, it's also AutoML solution, but it doesn't require any code or any knowledge of ML. It's used by business analysts. You can simply upload the CSV data, select the model to predict, and Canvas will build it for you and make predictions. It can be used in classification or regression, and it do automatic data cleansing for you, such as missing values, outliers, duplicates. You don't need to worry about that. Some of the prominent use cases for Canvas could be to predict employee churn, fraud detection, inventory optimization, sentiment, image classification, or in-time deliveries. Okay, this takes us for the end of the explanation of the content of the modeling section. This is very heavy section, and it has a lot of concepts that you need to be aware of. I would advise to take what we explained in this video as exploratory video for you, where you need to know what are the topics, and then you need to study more and read more about all the features of AWS SageMaker, what are the available built-in algorithms, what does each built-in algorithm help us to solve, what are the hyperparameters, how to train these algorithms, what are the training options, what are the deployment options, how to follow deployment, how to apply training. I would advise you also to go through some notebooks which help you to bring your theory into practice. And definitely you should make sure to revise all the basic data science concepts, such as what are the ML problems that we have, ML solutions, simple examples, how to evaluate a model, which performance metrics to use. These all are important concepts for the AWS ML examination that you should make sure you are confident to answer any question which comes through your way while sitting for the examination. And now we will go through some sample questions which help us to test our knowledge. Question number 1. First of all, we need to read the question, look for keywords, and try to think of some potential answers before reading the answer choice. So you are working as data scientist for a pharmaceutical company. You are collaborating with other teammates to create a machine learning model to classify certain types of diseases on image exams. Which type of metric would you use to optimize the underlying model? So the keywords that we should look into here is like we need to classify certain types of diseases on image exams. So here we are trying to identify disease. So it's like something which we need to be aware of true positive here. So we need to identify as much as true positives as we want, and we to reduce false negatives. So in this case, we should think of recall. And if we look at the options that are available, recall, precision, R-squared, F1 score. So R-squared, it's not a metric which is being used in classification, which can take it out. And we still have F1, precision and recall. But since we are working on a problem which entails diseases, and we want to identify as much as real positive as we want in this case, then we need to choose recall. So option A is the correct answer. Question number 2, what methods of hyperparameter optimization does Amazon SageMaker provide? We did cover this in the previous slide. And for hyperparameter optimization in AWS SageMaker, we have Bayesian optimization and we have random search. So if you look into the options, option B, random search, is correct, and option D, Bayesian optimization, is correct. So B and D are the correct options in this question. Question number 3, they are telling us a large consumer goods manufacturer has huge sales history of products available in Amazon S3, and currently the company is using custom-built autoregressive integrated moving average, which is a time series model, to forecast demand for these products. The company wants to predict the demand for new product that will soon be launched. Which solution would be machine learning specialist apply? Should a machine learning specialist apply? So the keywords that we should look into here have a huge sales history, okay, which entails we have different time series. We're using Arima, and Arima wasn't successful anymore, and they want to move to a new product that will be launched soon. So if we go into the options, we have first option, train a custom Arima model to forecast demand for the new product. Train an Amazon SageMaker Deep AR to forecast demand for the new product. Train an Amazon SageMaker K-means clustering algorithm to forecast demand for the new product. Train a custom XGBoost model to forecast demand for the new product. So because this is like a time series forecasting model and we have a huge sales history, then Deep AR would be a very good option here in order to train it and to forecast the demand of the new product. So it will be the best option. K-means is not being used for time series, and they were using ARIMA before and they want to move away from ARIMA, so option A wouldn't be useful. Option C is not useful, and option D, custom XGBoost, will be like more time consuming. So we can simply load the deep IR algorithm and use it as a forecasting model to forecast the demand for the new product. So option B is the correct answer here. Question 4, they are telling us you are working in a machine learning team to build and plan to operationalize a machine learning model that uses deep learning to recognize and classify images of potential security threats to important government officials using stills taken from live security video. So we're taking data from live security video. However, when your team runs their many batch training of the neural network, the training accuracy oscillates over your training epochs. What's the most possible cause for your training accuracy problem here? So keywords here, training accuracy oscillates, many batch training, and what's the probable cause for that? So we did cover that. We did cover that on our previous slides. And while training deep learning networks, we need to look into learning rate and batch size. And when the learning rate is high, then this might like help us overshoot the correct solution and to miss outliers, and the training accuracy will oscillate. So as a rule of thumb, when training the deep neural network, we should opt for low learning rate and low batch size. And if we look into the options here, option A, the validation error has stopped decreasing. Option B, the many batch size is too small, which is good. The many batch size is too large, or the learning rate is very high. Because they are telling us that training accuracy oscillates, and when training accuracy oscillates, this means the learning rate is very high. So option D is correct. Question 5, they are telling us a machine learning specialist has created a deep learning neural network model that performs well on the training data, but performs poorly on the test data. So we have an overfitting problem here. Which of the following methods should the specialist consider using to correct this? I have to choose 3. So here they are telling us that they are creating deep neural networks. This is the first keyword. It performs well in the training data, but performs poorly in the test data. So we have overfitting problem here. And when we have overfitting, we can think of increasing regularizations as to add L1 or L2. We can think of adding dropout. So if we go into the options we have, we need to choose 3. Decrease regularization, which will not help reducing overfitting. Increase regularization would help reduce overfitting, so option B is correct. Increase dropout also would help. Decrease dropout wouldn't help reducing overfitting, because we need to increase dropout in order to make the model learn the patterns of the training data and learn the patterns of training data properly and have a good performance test data. Increase future combinations or decrease future combinations. And here, because the model is learning the training data well, so we need to think of reducing the future combinations, which make the model more simple, which help it like learn the patterns better on the training data. And when we give it the test data, it will give the same performance. So it wouldn't overfit. So in this case, we should definitely choose option B, increase regularization. We should choose increase dropout, and we should also think of decreasing future combinations in order to make the model to perform good on the train test and the test set as well. Question 6, they are telling us you work as a machine learning specialist for a small startup. The founder of the company needs you to quickly build a model to test one of the team's minimum viable products or MVPs with the intent of preserving or pivoting depending on the outcome of your model experiment. You have decided to use SageMaker Autopilot to create your experiment. You have selected the S3 bucket, data source, and target feature for which to make predictions. You are now ready to select the machine learning problem type and objective metric. which are the viable combinations for your selections. So keywords to think of here is we need to use autopilot, and we need to select the data source and target feature to make predictions. So, and they are telling us that we need to we need to help the team who's building the MVP to use the model depending on the outcome of our model experiment. So we have to choose the correct problem type and the problem objective matrix. So if we look into the combinations here, problem type multi-class classification, object AUC, problem option B, regression objective F1, option C, binary classification objective MSE, which is mean squared error, or option D, regression objective mean squared error. So if we look into the options, the most compatible one would be to choose regression. And within regression, we can choose mean squared error, which is one of potential performance metrics for regression. So option D is correct in this case. We can use regression, and for regression, we can use mean squared error as our objective metric. So this takes us to the end of this video, where we did talk about modeling in depth, which is the most important section of the AWS ML examination. However, you need to go further. You need to read more about each of the topics we talked about and make sure you are confident on answering any of the questions that come through your way in the examination, where we'll be talking about the final section of the exam, which is about ML implementation and operation, and which weighs 20% of the total exam content. We'll be following the same strategy as in the previous videos, where we'll be discussing the content, and then we'll end up with sample questions which help us test what we learned. If we start giving a brief overview about the content of the section, this section aims at covering the concepts and best practices for managing, deploying, and monitoring machine learning models in production environments. If we go into the main topics that will be covered in this section, it will be mainly about Docker containers. We're going to talk about SageMaker and VPC, which we already did touch on it in the first video of the course. We're going to talk about SageMaker logging and monitoring, how to choose the right instance, what's auto-scaling, some of the AWS SageMaker features like Neo and IoT Greengrass. We're going to discuss inference pipelines, serverless inference, production variants, model registry, and we'll have a section to talk about the high-level AI services which are available in SageMaker, such as extract, transcribe, personalize, comprehend, poly, lex, forecast, and translate. And as I said earlier, we're going to end up with some sample questions. To start, talking about Docker. So SageMaker provides pre-built Docker images for its built-in algorithms. So whatever algorithm we end up choosing from AWS SageMaker, like linear learner, XGBoost, sequence to sequence, these models or algorithms, they have their own pre-built Docker images that we can load it from ECR, as we discussed in the SageMaker architecture in the previous video. And these Docker images, we can load it from there, and the supported deep learning frameworks, which we can use it for training and inference. So using these Docker containers, you can train your machine learning algorithms and deploy models quickly and reliably at any scale. So we can load the training code image or the inference code image from the Elastic Container Registry, and we simply train our model and we bring it to production using Docker. The next topic is about SageMaker and VPC, which we did talk about in the first video, and VPC stands for the Virtual Private Cloud. And it's good to know that SageMaker training jobs runs in VPC, and we have what we call the VPC endpoints, S3 VPC endpoints, with Amazon SageMaker is used to ensure data security and privacy, and to make sure that data is not going through the public internet, and there is a private connection between the VPC and the SageMaker services or S3. If we want to see the logs and monitor and alarm the invocation and the latency of endpoints, we can use CloudWatch for that. So CloudWatch helps us to see logs and to monitor and alarm the invocation and latency of endpoints, and to make sure that everything is running smoothly and no errors are being captured. Whereas CloudTrail, it helps us to record actions from users, roles, and services within SageMaker. So if we sum it up, CloudWatch can log, monitor, and alarms on invocations and latency of endpoints, whereas CloudTrail helps us to record actions from users, roles, and services within SageMaker. We also did talk about that on the previous video. When we are creating our notebook instance in SageMaker, we have to choose the proper and correct instance type. And in general, deep learning algorithms requires GPU instances, so we have to choose P2 or P3 for training. Whereas if we want to choose an instance type for inference, inference is usually less demanding, so we can use compute instances such as C4 or C5. So we need to know that for deep learning algorithms, also it's preferable to use GPU. P2 and P3 are good examples. And for inference, we can choose less demanding instance types. And for that, we can go for compute instances like C4 or C5. Automatic scaling. Automatic scaling, it's a capability which helps us to dynamically adjust the number of instances provisioned for a model in response to changes in the workload. So if we have more workload, then auto scaling will bring more instances online. Whereas if we have less workload or the workload decreases, auto scaling removes unnecessary instances. So that's what helps us to avoid paying for provisioned instances that are not being used. It's like cost effectiveness technique that helps us to remove unnecessary instances that are not being utilized efficiently. Inference pipeline. Inference pipeline, we can think of it as a linear sequence of 2 to 15 containers that would combine different stages of ML cycles, such as data preprocessing, model training, predictions, post-processing. And inference pipeline, it helps us to perform real-time inference and batch inference as well, or batch transforms. So whatever deployment option we choose, we can aim to use inference pipeline for that. The next topic is going to be about SageMaker Neo. And Amazon SageMaker Neo, it uses a technology called model optimization, where it optimizes a trained machine learning or deep learning model for us and helps us to be deployed for specific target devices and platforms. That's in a nutshell, what does SageMaker Neo do? It produces a compiled and highly efficient version of the model that can be deployed on edge devices with reduced memory and computation requirements while maintaining accuracy. So if we have like a big trained deep learning model and we want to bring it to edge devices, we can use SageMaker Neo to reduce the memory and the computational requirements of this model without like touching or like reducing accuracy, and then we take it to the edge device. So it optimizes the model for deployment in edge devices. Whereas AWS IoT Greengrass, it extends cloud capabilities to edge devices, allowing them to perform computing tasks locally and securely, even if they are not connected to the cloud. So if we want to bring a model to the edge device, first of all, we need to think of to think of SageMaker Neo to do the model optimization. And in order to make the model to run on the edge device without the need to connect to the cloud, then we have to think of AWS IoT Greengrass. This is where like IoT Greengrass and AWS SageMaker Neo can work together. So AWS IoT Greengrass can ensure getting the model to an actual device without the need to connect it to the cloud. If we combine SageMaker Neo and IoT Greengrass together, Neo can do the model optimization. So Neo can compile and optimize the model. And IoT Greengrass can get the model deployed to the device you want without the need to get connected to the cloud. The other feature that we cannot talk about is Amazon SageMaker's serverless inference, which is purpose-built inference option that makes it easy for you to deploy and scale machine learning models. So serverless inference is ideal for workloads which have ideal periods, where you can create serverless endpoints, automatically launch compute resources, and scale them in and out depending on the traffic. So if you have more traffic, you will get more compute resources, and if you have less traffic, you will have less compute resources. And this is also avoid us paying more costs for compute resources that are not being utilized efficiently. So Amazon SageMaker Serverless Inference, it helps us eliminate the need to choose instance types or to manage scaling policies, because it will manage these policies for us on our behalf, and it will increase or decrease these compute resources based on the amount of traffic that we receive on the model. Production variants is another topic which refers to the different deployment configurations or instances that host your trained machine learning models for serving real-time predictions. So if you are bringing a machine learning model to be deployed for real time with like interacting with end users, we can think of creating multiple variants of this model with different instance types to handle varying workloads and serve predictions at scale. Also, prediction variants could be used in case of doing A/B testing, where we need like to bring two versions of models for people. Then in this case, we can use multiple variants, or like we can use production variants to have different instance types to handle varying workloads depending on the business strategies on launching and deploying the ML model. Horwood is distributed deep learning training framework, which can be used for TensorFlow, Keras, PyTorch, and Apache MXNet. And it's available on AWS SageMaker. It's good to know that Horwood was originally developed by Uber to make distributed deep learning fast and easy to use. The next topic we're going to talk about is model registry, and model registry helps us to track model versions. So if we are like refining and developing the model, and we'll have different model versions, model registry can help us to track these model versions. It can group models by use case, and it helps to manage the approval status of a model by ML engineers based on the performance matrix. It helps us to deploy models to production and to automate model deployment with CI/CD. The next section that we're going to cover is the high-level AWS AI ML services. And we're going to start talking about Amazon TextRect. And Amazon TextRect is a fully managed machine learning services that automatically extracts printed text, handwriting, and other data from scanned documents, such as financial reports, medical records, tax reforms, and university application forms. And it goes beyond the simple optical character recognition that can be done by Python. So it identifies, understands, and extracts data from forms and tables as well. So if the question entails something related to extracting printed text from PDFs or understanding and extracting text from forms and tables, then we have to think of Amazon TextRect as a potential solution for that. The next service is Amazon Comprehend, and Amazon Comprehend uses machine learning to help uncover the insights and relationships in unstructured data, which is text data, such as input social media, emails, web pages, documents, transcripts. And for medical records particularly, we can use Comprehend Medical. So Comprehend Medical is like a special version of Amazon Comprehend, which deals with medical records. So Amazon Comprehend extracts key phrases, entities, sentiment, language, syntax. Within Amazon Comprehend, you can train your own custom model on your own data. If the question entails something related to studying sentiment, document classification, then we have to think of Amazon Comprehend as potential AI solution for this. The next service is Amazon Translate, and Amazon Translate, from its name, it does text translation service, which uses state-of-the-art deep learning to provide high-quality translations to customers without the need of any deep learning knowledge. It's used to translate text from various languages. It could be Spanish, Arabic, Greek, German, French, etc. Again, if the question entails translating, and they're asking for the best AI, for the available AWS AI solution, then we have to think of Amazon Translate as a good solution for this. The next service is Amazon Transcribe, and Amazon Transcribe, it simply transcribes voice data. So we give it voice data in terms of MP3 files, for example, and it helps transcribing or transforming this audio to text without any prior machine learning knowledge. So what's unique about all of these services we're talking about is that it doesn't, the one who's using these services, they don't need to have like knowledge about deep learning frameworks or how to train or deploy. So it's giving you like a ready service, and you just give it your data, connect to the API, and it does the work for you. Amazon Transcribe, it also includes speaker identification. So like if we're talking on like in call center, it identifies agent versus customer. It has automatic language identification, channel distribution, PII identification. PII stands for personal information identification. And you can include customer vocabularies as well. And within Amazon Transcribe, you also have Amazon Transcribe Medical, which is an ASR service that enables you to transcribe medical audio, such as patient-to-physician conversations. So far, we did say that Comprehend and now Transcribe, they both have special versions which handles like medical data. Amazon Transcribe Medical handles medical data, and Amazon Comprehend Medical also handles like medical data as well. The next service we're going to talk about is Amazon Poly, and Amazon Poly, it converts text to speech. Transcribe converts audio to text, and Poly converts text to speech or text to audio. The user provides some text either as plain text or using a syntax called SSML, and then Poly reads this syntax and generates a lifelike voice using one of the pre-built voices. We can use English, Arabic, Spanish, or Russian in order to transform the text to speech. The next service we're going to talk about is Amazon Recognition, and Amazon Recognition is an AI service which is used to implement image or video analysis workflows into their applications. Some of the business use cases for Amazon Recognition could be image classification, object detection, facial recognition, celebrity recognition, people paths, or to simply detect text and image. Amazon Forecast is another fully managed service within SageMaker, which is used to deliver high accurate forecast, also without the need of any machine learning knowledge. The forecast service, it uses machine learning to combine time series data with additional variables to build forecast. It also implements AutoML, so you give it the data and it will choose the best model for your available time series. These models could be ARIMA, DeepAR, ETS, MPTS, CNN. And I would advise you to go to the Amazon Forecast documentation and try to understand the differences between these models. Some of the use cases for Amazon Forecast could be retail and inventory forecasting, workforce planning, or travel demand forecasting. The next topic or AI service we're going to cover also Amazon Lex, and Amazon Lex is used to build and deploy the chat interface and respond to user intent. So it's used to build chatbots, in other words. In this context, we can think of an intent is an action you want the bot to perform, and an utterance is what the user actually asks for. And a slot is the set of parameters. So in order to build Amazon Lex, or in order to build chatbot, you need to think of your intent, your utterance, and your slot. If you take an example, let's say you are building a chatbot for pizza delivery, and if you are ordering a pizza using this chat box, the utterance could be, I would like a pizza. The intent could be order pizza, and the slots can be size. And the slots value could be either small, medium, large. So Amazon Lex could be used to build chatbots, and you need to know what's an intent, what's an utterance, and what's a slot in the context of building a chatbot using Amazon Lex. Amazon Personalize is also another AI service which allows businesses to rapidly develop personalized recommendation systems to provide a better customer experience to their end customers. There are two available APIs within Amazon Personalized. First one is called Get Recommendations, which get recommended products or content for users, or Get Personalized Ranking, which rank a list of items to be provided to customers. So Personalized is used for building recommendation systems, and there are two APIs there: Get Recommendations or Get Personalized Ranking. This takes us to the end of the content of the MLOps section, and now we will start tackling some of the sample questions. But before that, as I said in the previous videos, I would advise you to take the explanation of this content like as first essential step for you, but you need to take note of each of the topics we discussed, and you need to go for the AWS documentation and read more about it, especially when we've talked about the AI services. Make sure to know what does each AI service do, and when to use it, and how to build it. I mean, how to code the API for this AI service and start using it. And also go into some sample codes for that. And also you need to know how to do monitoring within SageMaker, what are the best techniques in order to reduce cost while bringing models to production, such as using auto-scaling or serverless inference. You need to know all of these topics, and you need to make sure you are confident to answer any question which would come through your way in the exam. If we start with the sample questions, first of all, we need to read the question, look for keywords, and then think of a potential solution. Question 1, they are telling us you work for an insurance firm trying to automate insurance claims processing. As a first step, you want to perform optical character recognition and extract forms and tables from PDF documents. What AWS service would you use to get started with this use case with minimal effort and quick outcomes? So we should think of automate insurance claims, optical character recognition, and extracting forms and tables. And it's going to be with minimal effort and quick outcomes. So we don't have to build a solution from scratch. And for optical character recognition or extracting forms and tables from PDF documents, we can think of Amazon TextRect. And if we look into solutions, we have AWS SageMaker, which entails developing a solution from scratch because we need to train a deep learning model for that. Amazon TextRect is option B, Amazon Candra is option C, and Amazon Comprehend is option D. And definitely we have to choose Amazon TextRect. So the correct answer for this question would be option B. Question 2, they are telling us an asset management firm would like to build a chatbot-based solution to automate advice given to their clients by their financial advisors. They are concerned due to their diverse global client base that chatbot will need to translate incoming text into English before the advice can be rendered. What services would you use to build this solution in a fast and efficient manner? Keywords here, chatbot, but they are concerned about diverse global clients and they need to translate as well. So we need to build a chatbot with translation. To build chatbot, we can think of Lex, Amazon Lex, and to do the translation, we can think of Amazon Translate. And if we look on the solution, Lex Translate is option A, and this is the correct answer. Question 3, they are telling us which AWS service would you use to view performance matrix from your SageMaker endpoint and set alarms and appropriate thresholds to auto-scale the SageMaker endpoint if they are surpassed. We did discuss that. So the keywords here, performance matrix and set alarms. And this is what Amazon CloudWatch do. So Amazon CloudWatch helps you to monitor the latency of endpoints and helps you to set alarms and thresholds to auto-scale a given SageMaker endpoint based on workload or traffic. And we see Amazon CloudWatch is option B, and it's the correct one. Question 4, which AWS service would use to log API calls made by users to Amazon SageMaker in their ML environments for audit purposes? We did also discuss about that, and for that we should use Amazon AWS CloudTrail. So AWS CloudTrail helps you to log or monitor the actions made by users. And Amazon CloudWatch, it helps you to monitor the latency of endpoints and auto-scale if there is a high incoming demand on traffic. So for this question, for logging API calls made by users, we have to choose AWS CloudTrail. So option D is the correct one. Question 5, they are telling us you are a machine learning specialist at a government agency that processes citizen applications for government documents. Your team is responsible to determine fraudulent activity in the document application process. You are preparing a subset of your agency data for model training in order to use your data in your SageMaker notebook. You have stored data in S3, and the data contains personally identifiable information, which is like high security data. In order to maintain the high quality of security, the data must be accessible only from your VPC, and it cannot traverse the public internet. Which option best meets your security requirements? So this is about networking and security. Keywords to look here. Keywords to look into here. Data is stored in S3, PII information, and the data must be accessible within your VPC, and it cannot traverse the public internet. So in this case, we have to think of VPC endpoints, which helps us to build like a private connection between our VPC and the AWS services without going through the internet. If we look into the options, option A, use VPC endpoint and leverage security group restrict access to VPC endpoint. Use a VPC endpoint and leverage a network access control list to only allow traffic between the VPC and S3. Use a VPC endpoint and leverage a bucket access policy to allow access to S3 bucket from the VPC endpoint. Or option D, use a VPC endpoint and leverage a bucket access policy to deny access to S3 bucket from resources other than VPC endpoint and the VP. So for sure, we want VPC endpoint. And we want something to do with S3 because the data is stored in S3. And because they are telling us the data must be accessible only from within your VPC, then we have to think of a policy which denies access to S3 other than the VPC endpoint and the VP. So option D would be correct, which helps us to build the VPC or use VPC, which leverage a bucket access policy to deny access to S3 from sources other than the VPC and the VP. If we look at option C, it's telling us use the VPC endpoint and leverage access to allow access to S3. We don't want to allow access for other users or the VPCs. We should only this VP should be able to access the S3. So we have to choose option D as the most correct answer in this scenario. The last question is question 6. They are telling us your machine learning team is responsible for processing video clips posted to your company's Twitter social media account to understand the sentiment of the video clips. Your team takes these video clips and labels them with the appropriate sentiment so that your marketing department can use them in their advertising campaigns. You will now need to translate video clips as part of your sentiment labeling process. I think I missed this line. So you are now expanding into Spanish and Portuguese speaking regions of the world and you need to translate video clips audio as part of your sentiment labeling process. What AWS services or SageMaker built-in algorithms allow your team to label the foreign language video clips in the most efficient manners? Keywords to look into here: processing video clips, so Amazon Transcribe, then understanding the sentiment of understanding the sentiment of the transcribed audio, so we can think of comprehend, and because we are expanding and we want to translate to other languages, we can think of translate. And if we look on the solutions, transcribe, comprehend, translate is option A, and this is the most correct answer because it will help us to process and transcribe the video clips and transform audio to text. And then after transforming the audio to text, we can use the text of this social media content in order to determine the sentiment. And then because we're expanding into different regions and we're thinking of different languages, you can translate this audio into other languages using translate. This takes us to the end of this section where we did discuss the content of the fourth section of the exam, which is MLOps, and we did solve some questions. I would advise you to review these questions and to try to solve it by yourself, and to further take the content that we discuss, read more about it, and make sure you grasp all the content with confidence. I hope you found it useful. Good luck on your exam preparation, and feel free to get in touch for any questions or feedback. Thank you for watching, and goodbye.